Alright, so in this video we're going to tackle a question from Gauteng province, June 2023. If we're going to look at this now, we're going to try and calculate the coordinates of line segment AB. So here's A, B, 3 and 9, 1 and -5. Alright, so I'm looking at it. B doesn't look like it's quite in the correct place. If A's x coordinate is 3, it's somewhere here. The over x value of 1 should be somewhere here, so which means B should have been somewhere here. All right, but let's not worry about that. These diagrams are never to scale anyway, so that's not really a problem. So we're gonna begin with 3.1. The coordinates of a midpoint are given as mx and my. Mx is x1 plus x2 over 2, while my is y1 plus y2 over 2. This is coordinate 1, coordinate 2. This is my x and y, x and y. So x1 is going to be 3 plus x2, which is 1 over 2. That gives me 2. For y, my y1 is going to be 9 plus my y2 coordinate is going to be -5 over 2. 9 minus 5 is going to be 4. 4 divided by 2 is going to be 2 again. So the coordinates of the midpoint of line segment AB is going to be 2 and 2. Alright, so that's straightforward. It's 2 and 2. The next one is 3.2.1. They want the gradient, so small m, of line AC, which is y2 minus y1 over x2 minus x1. So line A to C is over here. Now this time, let's say raise those there. This is my coordinate 1. This is coordinate 2. It comes first. The gradient, so this is going to be x, y, x, y. So my y2 value is going to be 9 minus my y1 value of 3 over my x2 value of 3 minus my x1 value of -5. So that becomes, what's that, like 6 over 8. So just check it on your calculator. Yeah, so 6 over 8, which is 3 over 4. Then we can also do the gradient of 3.2.2, which is the gradient of CB. Alright, that's equal to y2 minus y1 over x2 minus x1. Now when you're looking at CB, this is my second, this is x, and this is y. So my y2 coordinate is going to be -5 minus my x2 coordinate, sorry, my y1 of 3 over 1 minus 5. So now when you're doing that, you got -5 minus 3 over 1 minus 5, which is equal to -4 over 3. Alright, so that's my gradient of AC and CB. Show that AC is perpendicular to CB. So 3.3, for perpendicular lines, when you multiply their gradient. So whenever they talk about parallel or perpendicular, it's time to think about gradient. Now for perpendicular, it's the gradient of that first line that is saying AC times the gradient of the second line, which is CB. And if this answer equals to -1, they are perpendicular, only if it equals to -1. So we work those gradients out above. 3 over 4 times -4 over 3, and you multiply them together, you'll get -1. Therefore we can say AC is perpendicular to CB, and that's my answer. 3.4.1, the length of line segment AC. So AC is over here. So the line AC, the length of it here is going to equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and AC is equal to that square root. X2 is going to be 3 minus 5 squared plus y, which is going to be 9. 9 minus 3 squared. So make sure you're checking these out. You have attempted the paper. All you're doing at this point is either you're just marking or you're just trying to get a clue because you've got stuck. All right. So do not watch these videos as if before attempting or before trying, because that you're beating the point of learning, of struggling. Right. So 3.4.2. Oh, sorry, this was 10 units, by the way. 3.4.2, you're trying to calculate the length of segment CB. So again, we put the same formula. All right, you write it in full. I'm just skipping that for now. CB is going to be 1 minus 5 squared plus minus 5 minus 3 squared, and that's gonna equal to the square root of 1 minus 5 is 6 squared plus alright, that's interestingly also going to be 10 units. Alright, and then they want you to determine the area of triangle ABC. So 3.5, the area of a triangle is equal to area of a triangle is equal to a half times base times your perpendicular height. So now let's look at this triangle. We've already shown that AC is perpendicular to CB. There's a 90-degree here. So when multiplying base times height in a triangle to get it, this formula only works for right angle triangles. So this is a right angle triangle, it'll work. You have to multiply the two lines that are perpendicular to each other. So it's this line times this line. So it's equal to a half times AC times CP times AC times CP. And you've already found those distances. So this paper did a lot of scaffolding. When they wanted you to prove perpendicular, they helped you find the gradients first. Though they didn't have to do that. They didn't have to give you this, but they could have just asked you this, and you would have needed to calculate those to use it here to get that. This paper made it really easy and guided you towards the answer. And here as well, because it's already helped you find those distances. So times 10 times 10. So that's going to be 50 units squared. Alright, and that's your answer for area. So it was a really good paper to practice through. You would have benefited a lot from attempting this on your own.